So we're doing the integral from 0 to 1 of this function, and I'm pointing out the product here because we don't have a product rule for antiderivatives. And instead of writing the cube root and the 1/4 root, I'm writing what's equivalent to that, which is to the 1/3 power is a cube root, the 1/4 power is fourth root. And what I would have my students do is distribute this in. So now it is a polynomial. And just remember that when you're multiplying with the same base, you add the exponents. So that would be 4/3. And then this one would be to the 5/4 power. So now we're ready to do the antiderivative, which is adding 1 to the exponent. And it might make sense to write it as 3/3 to help you add 1. I don't know. I just assumed you knew how to do that before. And then multiply by the reciprocal. So this one you're adding 4/4, which is exactly what I did over here. So it's really the same math, but then multiply by the reciprocal. I should be putting equals in here, by the way. And we're going from 0 to 1. So what's really nice about this problem is when you plug in the upper bound in for your x's, well, 1 to any power is just 1. Think of the cube root of 1 is 1, to the 7th power is still 1. So we're just looking at 3/7 plus 4/9. And then you'd be subtracting off. And I still encourage all my students to put in zeros in there, just because when you do like cosine of 0 or e to the 0 power, you actually get numerical values. So this case, you do not get anything. Subtracting 0 is not going to change. So I would get the same denominator in these two. And what I'd have to do is multiply this piece by 9/9 to get that denominator of 63. So we're looking at 27. And over here, I'd have to multiply by 7/7 to get 28 as that numerator. And when you add those, you get the correct answer of 55/63. There you go.